Today we're going to take a look at linear relations. And to start with, we're going to take a look at how we would graph items in two dimensions. We looked at number line graphing earlier in the semester, and this is an extension of that idea. We are going to be having ordered pairs, and you'll notice that ordered pairs are labeled XY. It's kind of alphabetical. On a number line axis, that would be our horizontal axis. Down here is the x-axis. And on that axis, a positive is on the right and the negative is on the left. And then the vertical axis is the y-axis with the positive on the top and the negative on the bottom. And what we're going to do is we're going to actually be given some ordered pairs, numbers in place of x and y. We're going to plot those points. And we'll get started right away over here. So our first one is the value 5, negative 2. So we're going to count 5 to the right. All right, because it's positive 5, and then negative 2 would be down 2. We'll plot a point, and this is point A. Point B is negative 5, 3. So there's negative 5, 5 to the left, and then 3 up, and that point is B. And then we have negative 1, negative 2, so we go left 1, down 2. That would be C. And 6, 2, so we go right 6, up 2 for D. All right, so broadening our idea to more of the description in this title was about linear equations, linear relations specifically. And so we're going to talk about what linear equations look like. Linear equations are those of the form y equal mx plus b, y equal b, or x equal b, where m and b are constants. So constants, remember, are just numbers. So you have things that look like, y equals 2x minus 7, right? Because the 2 would be m, the negative 7 would be b, and those are constants. Or you would have something like y equals 3. Or maybe you have something like x equals negative 1. These would all be examples of lines. We're going to take a look at a specific line. This is the line y equal 5x minus 2. And what we're going to do is we're going to use that rule, that equation, to figure out if x equals certain values, what does y equal? And this is much like when we were evaluating expressions about a week ago. And what we're going to do is we're going to simply plug in the number. In fact, I'll start it like this, y equals, and the number that it gives us for x. So this would be 5 times negative 2 minus 2. So 5 times negative 2 would be negative 10, minus 2 would be negative 12. And we'll keep going. So now we have 5 times negative 1 minus 2. Well, 5 times negative 1 is negative 5, minus 2 would be negative 7. The next one, 5 times 0 minus 2. So we just get the negative 2 from the end. The next one would be 5 times 1 minus 2. So 5 times 1 is 5 minus the 2. We finally have our first positive value, 3. And the next one was when x is 2, excuse me. So 5 times 2, of course, is 10 minus 2 would be 8. Now what I'd like for you to notice is when you're going sort of down this table, in the x values, you're increasing from line to line by 1. And if you go down in terms of the y values, you're increasing by 5. And the reason that's happening is if you take a look back up at the equation, there's a 5 right here in the place of what we call the slope. It's telling you that for every one change here, you get a double change in y. Not double, I'm sorry, it's a double, but 5 times is what I meant to say. Looking at the 2 over there. 5 times the change in y. Right, so if x is 1, it's 5 times 1. If x is 3, it's 5 times 3, and so forth. A couple of application type things that we often talk about when we talk about line segments is distance and midpoint. So distance is our first one to talk about today. Distance is simply the length of the line segment between 2 points. And the formula for finding that is the square root of the difference in the x value squared plus the difference in the y value squared. And what I'd like for you to sort of make note of is the fact that when you square things, the order of the subtraction inside doesn't matter. right? So like if I did 5 minus 2 and we squared it, and you did 2 minus 5 and we squared it, we will both end up with 9 because it was 3 and negative 3 then squared. So the order of subtraction doesn't matter. You have to make sure that the x's stay together, that the y's stay together, but other than that, the order is unimportant. So let's take a look at finding a particular distance. So we have two ordered pairs given. One is 2, negative 3, and the other is negative 2 and 1. So we're going to find our distance, which is the square root, and we're going to do the x value subtracted. I'm just going to go from left to right. So I would do 2 minus negative 2. If you do it the other way, totally fine. We get the same answer. And then on the y values, I have negative 3 minus 1. Now you'll notice the directions say that we're supposed to find this answer to exactly the right value, not approximation. So negative 2 minus 2, this would be negative 2 plus 2, right, is 4. So I've got 4 squared here. And then negative 3 minus 1 would actually be a negative 4 squared here. Now they don't always work out to being 4s or matching or anything like that. That's of course just happenstance. But on this one, I have the square root of 4, which is 16. I'm sorry, I have the square of 4, which is 16, plus the 16, which would be the square root of 32. If we take 32 and we factor it down, maybe we try 4 times 8 first, and then 4 is 2 times 2. And interestingly enough, 8 is also 2 times 2 times 2. So I have 5 2's. Okay, got them all in there finally. 5 2's, and because it's a square root, we're looking for pairs of 2 items, right? So these are my pairs that I have. So of course, if I've got a pair of 2's, it comes out as a 2. Another pair of 2's comes out as a 2, and then I have square root of 2 for a grand total of 4 square root of 2. That would be the exact answer. All right, so midpoint's another item that we're going to take a look at in this section. Midpoint is the rotation on the number line segment containing 2 points, such the distance to each point from this location is equal. And you'll see that this formula given below is averaging values. So we take x1 plus x2 and divide it by 2. That's an average x value. And the same thing, for the average y value in the y term. So we're going to find one, of course. Same points we had before when we found distance, a and b. So we're finding the midpoint. I'll just call it m. We want to add the x values together, so it's 2 plus negative 2, and then over 2. And then we're going to add the y values together, which is negative 3 plus 1 over 2. All right, so negative 2 plus 2, that was a 2 plus negative 2. There's my negative. I knew one of them was negative. There we go. That actually gives me 0, right? 0 over 2. And then negative 3 plus 1 would be negative 4, not negative, negative 2, there we go, over 2. And if we simplify this, we have the ordered pair 0, negative 1. All right, a couple more things before we end this section. The first is something we have seen before. It's a definition that says a value is a solution if it makes an equation true. Now, some of you, in fact, many of you, on the last homework assignment that I handed back in class from section 12, instead of actually just checking to see if these solutions were true on that particular problem, you actually solved the equation to find out what the equation's solution is. Neither one are bad. They just lend themselves to different things in different ways. So I'm going to take a look with you at finding solutions when we actually are given an equation and we're given an ordered pair, and we're deciding if they're actually going to work with the equation. So the equation we're given here is simply x equal 5. So what you'll notice about this equation, of course, is there is no y, which means really all I care about the x values testing in order to see if things work. And what I'm doing is I'm plugging in each value for x and checking to see if it equals negative 5. So I've got negative 4 clearly does not equal negative 5, right? So this is not a solution. The next one is 6, and also that clearly does not equal 5. So it's not a solution either. And the last one is -5 equals -5. I realize I left the negative off up here. Let me fix that while we're here. All right, so yes, clearly those are equal. So this one would be considered a solution of the equation. Now, sometimes you'll have just one solution. Sometimes you'll have no solutions. We have all the different kinds of things that might happen. But there is a solution on this particular one. All right, so we're going to try another one that has x and a y in it. So on this one, we're just going to be plugging in the x in place of x, so it's 2 times 1, plus the y in place of y, which is 5. Clearly that gives me 2 plus 5, which is 7, and 7 is a solution because it says 7 on the right-hand side. I can do 2 plus 2 plus 2. So, of course, 2 times 2 is what I meant to say. 2 times 2 is 4, plus 2 would be 6. And so that one doesn't work. And the last one we're going to test is 2 times 3 plus 2 times 1. Not 2 times 1, just 1. There we go, 1. And 2 times 3, of course, is 6, plus 1 is 7, and so that one also checks. So for those are the 3 that are solutions, or of those 3, those are the 2 that are solutions. All right, so what if you're not given sort of values to test and you're just given an equation and you're told to find solutions? So that's exactly what's going on number 10. Number 10 says find an ordered pair that is a solution to the equation. -3x plus 2y equals 5. Okay, so the reality is we have quite a bit of freedom. We can choose any x value that we'd like, and then we can use that to find the y value. Or vice versa, we can choose any y value we like and choose that, and then determine that your x value from that. So I'm going to just choose to have x equal to -1. And the reason I am is because it'd be really nice if I had 3 plus 5 on the left. And I can do that if the x value is -1. And then I have 2 times y, so of course y is determined by x. So if I actually let x equal -1, then you're going to end up having 3 on the left, 5 on the right, which means you need 2 more on the left for a value of 2. So here's what I'm saying. If I had -3 and 2y equals 5. So if we know what the x value is, we can literally plug in that value for x, and the only thing that will be unknown in the equation is y, and we can solve that for y pretty quick. Another one might be to choose something to be 0. It's really pretty friendly on this one. If I choose this to be 0, is 0 is out this piece, but then I have 2y equals 5. I divide by 2 and I get 5 halves. So what I want you to know about this is that this should give you sort of the sense that there isn't just one solution. There are infinitely many solutions when we look at these problems.